Let's see. Okay, isomer, which is also called isomerism. All right. So I'm not going to waste time here. They say definition: structural isomers are compound with some molecular formula but different structural formula. When you draw them, it looks different. So you've got chain isomers, which is molecules with the same molecular formula and in the same homologous series, but different types of chain, butane, and so forth. You don't need to know this. You just need to know what they are. Here's number one, chain. Chain means, like I said, you can have your chain in a straight line. 1, 2, 3, 4, and then 5. And then the very same chain with 1, 2, 3, 4, 5, you can bend it, you can write it in different forms. I've got 3 now, then I can say 4, and then I say 5. That's all. Then you got different names, but the number of carbons, hydrogens are the same. Did that make sense to you?
Yes, sir.
You didn't change everything. Every carbon was there. Every hydrogen is there. It's only the arrangement you did. You didn't go straight. You go around the corners, having branches and so forth. So what is chain isomers? I take a normal chain, I branch it out however I see fit. That's all. You happy? It's done, this one. Can you see how easy it is? Yeah. All right. Then we're going to positional isomers. Remember when I said alcohol and the carboxylic acid, those functional groups, you found them by the boundaries. You don't remember? Like I gave an example, I said you got C. It's not sandwiched. So I'm gonna go up, down, left, up, down, up, down, up, down, and then up, down. Meaning, what's happening? I can put the OH here, or if I want, I can move it. I can go put it over there. I'm changing the position of OH, or I can put it over there, or I can go put it over there. Can you see that? I can put it anywhere I please, here or there 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 or there. I'm repositioning. That's positional isomers. One example, you can see it's the same thing. Here's OH. Somebody said, why don't you put it next door here on the outside? That's exactly what happened. We just moved it. It's moving a piece of a chess. You're playing chess, you move a piece. That's all. Okay, this one, what is it? It's how you're building your structure. Same blocks, but you different. This is like doing the logo. What do you call those building blocks? They level logo, whatever. Yeah.
Lego.
Lego, yes, that's right. Because you can put them in a straight line or in a different way, but they are the same number. They don't change how many they are in the box. Yeah, that's right. Here you've got the same structure. You only move one of the thing. It's like those Lego. You only move one block. You can put it there, that block in the beginning, at the end, in the middle, anyway, all around. But you're just going in a boundary, not in the middle, so to speak. That's it. Then we go to the third one. The third one is a functional isomer. Okay? Now, when it's a functional isomer, like I told you at first, you've got an alcohol. I said you've got alcohol. Its partner, it's an ether. It's an ether. And then you also had, we call an aldehyde. Aldehyde, the partner of the aldehyde, it's actually a ketone. I call it cat1. And then you've got carboxylic acid. Carboxylic acid, we could say it partners with an ester. Let's just do that. So the one that I'm underlining, they are in the boundary.
Yeah.
The one I did not underline, they find themselves in the middle. So what's happening with functional isomer? You're working with the boundary and the sandwich one, red with red. Alcohol becomes ether. Aldehyde becomes ketone. Carboxylic becomes ester. So how did I say it happens? Last time I told you, it's like you're having R and then an OH. And then the other,
Yeah.
you've got an R and an R. You see, you got, yeah, exactly. That's exactly what's happening. All right.
Yeah.
So let's look at the two, these guys here. Here you've got this one, it's in the middle. Can you see that?
Yeah.
Yeah, it's in the middle. It's a ketone, it's in the middle. But now that stuff, now you move it, you put it right at the end. So which means, okay, let me put the functional group like this. Let's do it this way. It's like that. So this is like the R now on its own. But you notice there's an H here. We could have put an R to sandwich it. So meaning this one here, we basically have an R on this side and another R hydrocarbon. Can you see that?
Yeah.
Yeah. So that's why when you say isomers, I was like, oh my gosh, because I knew you needed to, if you're doing alcohol, you must not say maybe the ether. Any of the two partners, maybe they'll give you this one. I don't know. That's it. There's no other. That's all. And then here it will be just an activity, whatever. You just check what happened there. That's all. So it's only 3. 1. Instead of drawing my structure in a straight form, I can go around the bend. Other one, it's the same structure. It does not change. I'm only moving one piece along the fencing. The other one, I'm sandwiching one of them. The other one becomes unsandwiched. It becomes boundary and sandwiched. That's all. Those are the thing.